Hi. Now we do the difficult part, the energy level diagram. What we did up until now is the easy part of the Born Haber cycle, which is the energy cycle diagram. Now we do a slightly more complicated part, the energy level diagram. I put it here side by side, energy cycle diagram and energy level diagram. They look different. Remember, instead of having boxes, you're putting horizontal lines, and on top of that horizontal lines you must put the substances, and you must put the arrow pointing up or pointing down. Next page, you have two steps, similar to the energy cycle diagram. Two steps. Step 1, we put the substances involved in the horizontal line. That's the first step. Second step, we put the arrow. The arrow represents enthalpy changes, either up or down arrow. Upwards for endothermic, downwards for exothermic. Next page. This is the pattern. The pattern for the Born Haber cycle. A1 plus A2, B1 plus B2. The lowest is D. D is the lowest. After that, A1 plus A2, B1 plus B2. C1 plus C2 is slightly higher. This pattern only applicable if the charge of the anion is -1. What is the reason? Is related to the second EA. Second EA is positive. Okay. Later we go into the more details here, but it's like this. C1 plus C2 is just slightly higher than B1 plus B2. Right? So the lowest is D. Higher than that is A1 plus A2, higher than that is B1 plus B2, slightly higher than B1 plus B2 is C1 plus C2. We must add two more horizontal lines, so total will be 6. Two more. B1 plus A2 between A1 plus A2 and B1 plus B2. C1 plus B2, the highest. The reason for that, because we are going to draw a downward vertical line from C1 plus B2 to C1 plus C2, which is the first EA. The first EA we are going to draw downwards. If the anion is -1, we put like this. The highest will be C1 plus B2. If the anion, the charge of the anion is more than -1, can be -2, -3, -4, for example, O2 minus, or S2 minus, or P3 minus, then the Born Haber cycle pattern slightly different. The highest line will be C1 plus C2. So it's very similar to the first part, with a slight difference. C1 plus C2 is higher than C1 plus B2 plus some electron. The number electron might not be 1. It can be some number, right? It can be 2, it can be 3, it can be 4. So I put it there. If the anion is -2, -3, -4, and so on, C1 plus C2 will be above C1 plus B2. That's why energy level diagram is slightly more complicated than the energy cycle diagram. And the reason for that difference in the pattern is because second, third, and fourth EA are endothermic. Endothermic, which means it will point up. That's according to my parrot. She say when an electron forms bond with an atom, enthalpy change is negative. There is a repulsion between negative ion and an electron. That's why the second ionization energy is endothermic. Next page. We put the first example, example 1. We already did the same, we are going to do the same experiment, example, sodium chloride, and we already put the substances there in the table. Then we put NaCl, Cl is -1, which means we use the first pattern. The highest will be C1 plus B2. Yeah, we use this pattern now. Then we put the first part, Na solid plus half Cl2 gas, that is A1 plus A2. B1 plus B2 is sodium gas plus Cl gas, atomic gas. Atomic gas. C1 plus C2 is Na plus gas plus Cl minus gas, gaseous ion. Then D, which is the lowest, is NaCl, solid. Of course, it's solid because it's an ionic compound. Right. We prepare the two horizontal line, which we are going to fill now. Now we put the in between A1, A2 and B1, B2. The sodium already changed into sodium gas, but the half Cl2 gas, we still put it as half Cl2 gas. And on the highest horizontal line, we put Na plus gas plus Cl gas plus electron. You have only one electron because you have only one Na, and Na is +1. So that's the first example. We are going to put the arrow later. Now for example 2. We already write down all the substances in the form of a table, which we are going to put into the horizontal line now. We use the second pattern because this example is magnesium sulfide, MgS solid. We are going to use the second pattern, which means the highest horizontal line is C1 plus C2. Then we put the first part, A1 plus A2, magnesium solid plus sulfur solid, B1 plus B2, magnesium gas plus sulfur gas, C1 plus C2, Mg2 plus gas and S2 minus gas. D, which is the lowest, MgS solid. And you see that we have two more horizontal lines between A1 plus A2 and B1 plus B2. The other one is between B1 plus B2 and C1 plus C2. And we are going to fill them up now. In between A1 plus A2 and B1 plus B2, we put magnesium gas and sulfur solid. That means we already atomized the magnesium, but we haven't atomized the sulfur. Then the in between B1 plus B2 and C1 plus C2, we put magnesium 2 plus gas plus sulfur gas plus 2 electron. Because magnesium release 2 electron because Mg is 2 plus. That's example 2. Example 3 is aluminium oxide, Al2O3. We already right, we already draw the table. We know all the substance we did in the previous section of this video. Then we fill it up. We use the second pattern because the anion, which is oxygen, is 2 minus. Then we fill up the first four. D, the bottom, Al2O3 solid. Of course, it's solid because this ionic compound. A1 plus A2, element at standard state. 2 aluminium solid plus 3/2 O2 gas. Don't forget to put the coefficient. You must have 2 Al and 3 oxygen. In this case, you must write 3 O2 gas because it is a diatomic molecule. B1 plus B2, atom at gaseous state, 2 Al gas plus 3 O gas. The highest horizontal line, C1 plus C2, 2 Al3 plus gas plus 3 O2 minus gas, ionic gas, cation and anion at gaseous state. Right, with the 2 empty horizontal line which we are going to put here, we are going to fill it up now. So in between you have A1 plus A2 plus B1, 2 Al gas plus 3/2 O2 gas. That means you already atomized the aluminium, but you haven't atomized the oxygen. Another one is 2 Al3 plus gas plus 3 O gas plus 6 electron, which means you already ionize Al. You already ionize aluminium, but you haven't do electron affinity for oxygen. 6 electron, because you have 2 Al and each Al release 3 electrons, so you have 6 electrons. Yeah, very simple. After this, the last part of this video, we need to put the arrows, which means is the enthalpy change of the reaction, the enthalpy changes. Please continue watching this video. Thanks.